Welcome to the fourth section of this course. In this section, we are going to be studying structural design patterns. Structural patterns help us to better realize and express the relationships between code entities. In this section, we will explore 5 of them: the decorator pattern, the adapter and facade patterns that are often confused for each other, the composite pattern, and the proxy pattern. In this video, we will study the decorator pattern. In this video, you will learn what a decorator is and how to use it to combine cards in our card game. The decorator pattern offers an innovative way to extend objects while following the open-closed principle that we studied in the first section. In case you can't remember what it is, the open-closed principle says that a class should be open to extension but closed to modification. Before we begin analyzing the decorator pattern, we must first describe the problem we are trying to solve. So here's a list of requirements we have for our application. We must be able to maintain multiple types of cards, and the cards should be combinable. All those cards should follow the same interface, so in the eyes of a class that consumes them, they should be identical black boxes, with different functionalities of course. Let's take a look at a more concrete example. Assume we have a soldier class. The soldier has 2 basic stats: attack and defense. This particular card's base attack is set to 25 and its defense is set to 20. We can combine this card with item cards to increase its stats. We can, for example, combine it with a sword and an amulet for an added 20 to its attack stat. As far as defense is concerned, we can add a helmet and heavy armor for a total 55 increase. We could turn these items into separate classes, but the decorator pattern offers a more elegant solution in which both the soldier card and the item cards inherit from a common base class. Both the item card classes and the concrete card classes inherit from the card base class. The item card is actually called a decorator though, and it holds a reference to a card. That's the defining factor that separates it from the rest of the cards. The question is, why would something that is seemingly a card hold a reference to an instance of its base class? Hold on for a little while longer and you will know the answer to that. First, let's take a look at the inheritance tree we end up with. We have a card base class that can safely be turned into abstract depending on your code. We have a concrete soldier instance inheriting from that base class, and we also have a card decorator class that should also be abstract. Our items all inherit that abstract card decorator class. Remember, there's a little distinction between the decorators and the soldier class. The decorators have references to a card object. Time to learn why. The goal of the decorator is to combine a single concrete class with one or more decorators. Starting from the soldier card of the previous example, we first decorate it with a sword decorator. That means that we are creating a new instance of the sword decorator, passing in the soldier object. What we get back from this initialization is actually a card, because if you remember, decorators are cards too, they extend the same class. Then we take that instance and wrap it inside an amulet for an increased attack stat. We do the same for the defensive decorators as well, and that is why a decorator holds a reference to a card object. Enough theory, let's break the task down and start writing some code. As a first step, I'm going to rewrite the card class a bit. We are going to change the public accessors and mutators, and we are going to only provide a getter. For the public, the rest are going to be protected properties. So we have a protected string for the name, a protected integer for the attack stat, and a protected integer for the defense stat. The next step will be to create a constructor to initialize it using values provided by the caller. That way we can say something like underscore name equals name and underscore attack equals attack and stuff like that. Now it's time to create the actual getters that are going to be virtual, and this is very important for the next steps. We make these getters virtual so that they can be overridden by the decorator. Remember, the decorator that we're going to be making will be extending the card class, and therefore we needed to be able to override what is returned when the caller attempts to access the name, the attack stat, and the defense stat. Primarily because of the attack and defense stats, but the name can play some role too to the whole thing. And the card class seems to be prepared. We can now move on to the next step of working with decorators. Inside the common project, we can add a new item. That will, of course, is going to be a card. We're going to name this card Decorator and hit add. This new class, of course, needs to be public. We never forget to include that, and it extends the card class. So we are going to use the inheritance notation followed by the name of the card that we want to extend, which is the card class. I automatically generate the constructor, but we need to modify it a bit. Remember that the decorator wraps around a card object, so we need to provide that card object to the constructor and make it immutable. This is one time only. We only initialize the card that the decorator wraps in the constructor. Therefore, we need to create a protected field. Notice that it has to be protected because something else will inherit from the card decorator. You can also make the card decorator abstract, but we'll stick with something simpler for now. Next, let's generate some overrides. I'm gonna use Visual Studio's assistance here. If you click Ctrl Dot in your keyboard while hovering over the card decorator, you can check which methods you want to omit from the generation, and since we only want to override the getters, that's exactly what we're gonna do. Inside the name getter, I'm going to combine the name of the card that is being held by our decorator with the name of the decorator. That way, when we change decorators, we are going to end up with a long chain of names separated by commas. That's great for readability. So I'm going to include both the name of the card. I'm going to put the name of the card first, followed by the name of the decorator. So in this place, we're going to have underscore name. Far more important are the attack and defense stats. In this case, we will be adding the attack stat of the decorator to the card's attack stat. I hope by now you understand why we had to define the getters as virtual methods. And of course, the same needs to be done for the defense stat. Just have to remove the generated code and replace it with a getter that adds up the card's defense rate with the defense stat provided by the decorator. We can now take it one step further and introduce different types of decorators. For example, we can have an attack decorator that only increases the attack stat. Therefore, when the user creates an instance of that decorator, they don't need to supply a defense parameter, because since this is an attack decorator, the defense will always be 0. So this isn't necessary for you to implement the decorator pattern, but it's a nice add-on that makes our code cleaner, and it's worth taking a shot to implement this. So as you can see, this is pretty straightforward. We're going to remove the defense argument, and instead, in the base class constructor, I'm going to replace the defense variable with 0. This is the only thing that we need to do, since everything else will be handled by the overridden getters that we implemented a few seconds ago. Now, we also need a defense decorator, so I'm going to go ahead and generate the defense decorator. This class, of course, also needs to be public and inherit from the card decorator base class. I'm going to auto-generate the constructor and remove the third argument, which in this case is the attack stat, and provide the value 0 to the base class constructor. This greatly simplifies how we initialize an attack decorator or a defense decorator, because not only does it reduce the amount of arguments that we need to pass in the constructor, it also makes it simpler to visually distinguish attack decorators from defense decorators. Of course, if you have a decorator that adds both value to the card's attack and defense, you're gonna have to use the card decorator, and that's one of the reasons why I didn't make it abstract. Now, inside the program.cs file, I'm gonna create a static private method called test decorators, just so we could quickly see decorators in use, since we're probably going to face some build errors if we attempt to build this project. Remember, we changed code inside the common class library, therefore we have probably broken the contract and the API may not work, the card service may not work, but we will revisit this in future videos to fix it. For now, let's focus on the decorators. Let's say we have the soldier class that we described in a diagram in the previous slides, and then we are going to simulate the added items. The first one is going to be the sword. So in the name, I'm going to place sword. And if you remember, it adds 15 attack power. And then we have a second item, if you remember correctly, with 5 damage. And now to the defense decorators. Notice that we always assign the value returned by the constructor by the initialization process to the soldier object, because both the attack decorator and the defense decorator are also cards. So we end up with something that has been wrapped inside a decorator, but the caller doesn't know that this has taken place. To the caller, to the class that uses the soldier, to this console.writeLine method, soldier is just a class. It can't see that soldier is actually a chain of 5 decorators, of 5 classes. So if we print the attack and defense stats, we're gonna get the total attack stat and the total defense value of that card. Back to the main method, I'm gonna comment out what we created in the previous video. Actually, we omitted a wait call here. I'm gonna fix that, and I'm gonna call test decorators, quickly run the project, and it fails because it attempts to connect to the API, which means that I forgot to remove the test API connection call. So I'm gonna comment this one out and run it again. This time it's gonna run and it will eventually print the correct values, but oops, again, I forgot something. I have commented out the console.read key, therefore the console immediately vanishes after the program finishes execution. We are now ready to witness whether our code worked or not, and you can see that we have the total stats, 45 for the attack stat and 75 for the defense stat. This is exactly what we measured the stats to be while looking at the diagram, and we successfully replicated that example in code with our decorators.